Okay, folks, in this video, we're going to continue where we left off, and we're going to begin discussing the p-value. Quick recap, though. In the previous videos, we have discussed setting up a hypothesis, evaluating the alternative hypothesis with a test statistic, and we've discussed a little bit about these conclusions and whether a large test statistic or a small test statistic, how that may provide evidence in support of the alternative hypothesis when the test statistic is large, and when the test statistic is small, that does not provide support for the alternative hypothesis. So what does it mean for a test statistic to be large, or what is near zero actually, what values does this imply? This is quantified by the p-value. P is short for probability, and this corresponds to a hypothesis test. This is a t-test that we're talking about. So this is a probability within the t distribution in some location. Our brief definition for right now is going to be that this p-value is the area under the t distribution in the tails beyond your test statistic, beyond the test statistic. I'm going to write plus or minus the test statistic. I also like to consider it as a measure of compatibility between the data and the null hypothesis. Let's look at a couple generalized examples to compare these two potential conclusions. Those conclusions being either we have support for the alternative hypothesis or we do not. So let's start with, what does a small test statistic look like and how that translates into this p-value. A small, maybe I should put that in quotes. A small test statistic in a t distribution with some degrees of freedom near zero. A small test statistic, it could be positive or negative. Perhaps you got a negative test statistic or a positive test statistic, just somewhere near zero. So I'll label this TS, and it was a little redundant, but I'm going to put a negative sign just to differentiate. Because this example of a test statistic is near zero, and this p-value is the area in the tails beyond your test statistic, and it is in both tails. Since this test statistic is near zero, this would be a fairly large area, right? So in general, a small test statistic will get you a p-value that is kind of large. And that large p-value, if you rewind or refer back to your notes, this is a conclusion of do not reject the null hypothesis. This is a lack of evidence for the alternative hypothesis. On the other hand, let's see what a large test statistic, what kind of p-value that may result in. T distribution, 0 degrees of freedom. A large test statistic would be considerably out here in a tail. It could be positive, it could be negative. This p-value is the area beyond the test statistic, further in the tail. So a large test statistic is going to result in a value, a p-value, that is small, indicating that the data are incompatible, not compatible with the null hypothesis. As such, our conclusion would be to reject the null hypothesis. Maybe you've noticed I'm still being a little vague. What is large? What is small? What on earth? Because the p-value is the primary tool we use to assess the strength of the data in support of the alternative hypothesis or not. And it's a p-value, it's a probability. We need to compare, or the way that this has been established is that we compare the probability, the p-value, to some threshold. This threshold is called, and you've heard of this, the significance level, the level of significance. Do you remember the symbol for that? Little fishy, alpha. Do you remember what alpha typically is? There are common values for alpha. Usually, alpha is quite small. Maybe 0.01, maybe 0.05, that's the most common, or maybe 0.10. We have seen these connected to confidence intervals, right? The significance level is complementary to confidence. Confidence. So 0.01 significance corresponds to 99% confidence. 0.05 corresponds to 95% confidence. And 90% confidence corresponds to alpha 0.10. We use this significance level to compare the p-value to. If the p-value is small p-value, I believe it's less than or equal to alpha. Alpha is small, so if the p-value is alpha or smaller, then we must have had a large test statistic. A big difference was observed, indicating we should, or the data suggests that we reject the null hypothesis. On the other hand, that's really the only one I remember because this next statement I'm going to write is just the opposite. If the p-value is greater than alpha, then the data suggests do not reject the null hypothesis. Okay, so that concludes the setup for a two-sample t-test. There is a hypothesis that the two means are equal and the null. The alternative states that there is a difference in the population means. We need to assess the strength of the data and if it supports the alternative or not. That is performed with the test statistic and ultimately the p-value. At the end of the day, one of the main relationships that you are going to remember is these relationships down here, maybe even just this first asterisk. Okay, so in the next video, we're going to look at a particular example and put all of this into play.